So I won't give you, and in some cases I may just tell you the exact questions that there. I won't tell you the answers today. You have to that there, but I'm going to tell you most of the questions right there. And let me go ahead and bring up OneNote here. You know, as I was leaving for class, everyone was saying drop hints on the finals. I don't drop hints. I actually just almost tell you what the final exam was. And this actually goes back to an old school thought of mine. Hey, I had a professor when I was a young person like yourself, who always made the comment that professors don't have to write difficult exams. Students will take an easy exam and make it into a difficult exam. That was his philosophy. I've since then learned that to be true. I did very well on exams because I realized that they were actually pretty easy when all said and done. And I was reading too much into them. And I actually take more points off for you giving me too much information instead of just answering the question and stopping there. You don't gain more points by giving me more information if the more information is wrong. So if I ask you, what is the value of pi, and you say 3.14156 or something like that, you get a right answer. But if you tell me that it's 3.1415692367889 and the last part of it's wrong, you're going to lose points. And believe me, I've done enough of that there. So as I look at the exam, there's 5 questions right there. 3 of the questions actually are very much like the midterm that I gave you that we did in class. Now I still have them sitting on the desk and I didn't give them back, but you remember the midterm. If you want, someone remind me and I'll post it back online. The questions, not necessarily the solution that there. I've got it stored on my hard drive, and it may be tomorrow or Saturday before I post it, but remind me to post the midterm. But I'm just going to read the questions here. Question 1 deals with types of motors. Motors and actuators. The question may read something like, first part, this is actually part A. Part A might be mention and explain the various types of motors, including, and I might mention things such as servo, hydraulic, pneumatic, DC, continuous servo, standard servo, but the various types of motors and actuators that we would use. And when I say mention and explain, give an idea where you would use a standard servo. I'll use that as an example. And you might say small robots such as the one that we used in class, right there. Explain where you might use a stepper motor. Again, you might be, mention something such as a CNC or a 3D plotter. I mean, they typically use stepper motors. Satellite dishes use stepper motors. That there. So a DC motor right there. So mention the various types of motors. Where would you use hydraulic versus pneumatic? What are the advantages of hydraulic? That there. And I'll give you a hint. If in order to use the place you would most likely use a hydraulic actuator is when you have to carry a heavy load. An example of that would be a robot that had to pick up the engine of an automobile to place it into a car would be where you would use the hydraulic. you would use a hydraulic motor in a car jack, in order to lift the car up in a garage. That there. Pneumatics, of course, are small. That there. You would use pneumatics for things such as little flippers to disregard potato chips on a potato chip sorting line. I know I mentioned the potato sorting machine, chip sorting machine. That there. So types of motors and actuators. B, I get into joints. We talked about a number of joints. There was a slide that we used early in the semester, and all the slides are posted in the Facebook group, so you can go back and look at the slides. But there is a slide that goes through and explains all the different types of joints right there. So, and I will just simply say, mention the various types of blank mechanical joints used, and then I may ask the difference between one type or another. Right? So the questions are, and of course it's because of Bloom's text, philosophy of teaching, that there I have to word the questions in an awkward way where I say mention and discuss, or mention and explain. But in other words, if I have the question, and I'll tell you right off, this question is on the test, so here's a freebie for you. Mention and explain the various types of motors for robotics, including, and I'm going to say DC is one. So in other words, what is a DC motor? Where is it used? And that there. Now, in this particular question, I don't ask you how to control the motors. I just ask, mention and explain the various types. You probably should include an example of where they're used as well. That there. I used to ask the question and give an example of one in use, and I do elsewhere in the test. If I ask for an example, I'm asking for a specific application example. So if I ask for an example of a position sensor, a GPS is not an example of a GPS sensor. An example of a GPS sensor might be a sensor on a robot arm to tell what angle it's at. So it may be a potentiometer, but you would use it to tell the position of an arm. How far a robotic car is from the car in front of it, that would be a position, an example of that there. But a GPS is not one of them. If I ask for an example of a pressure transducer, a LVDT is that one, but one, something to tell the barometric pressure, of a mountain climber on a mountain, right there. Or how deep a submarine is, that would use a pressure sensor or something. So that's B. C, again, is an essay. I can't tell you what the essay question is. I gave several examples in class. I mentioned things like what would happen if I had a factory and I had an assembly line that needed to be automated. What would be the effects of automating an assembly line with 15 employees that are going to be put out of work? That there, and the robot costs so much. What would be the effects? That there, I might. That there, another one I asked for. I talked a little bit about is, autonomous vehicles or self-driving cars. What is the effect of switching all the trucks or delivery vehicles to autonomous vehicles? Amazon is doing this in the U.S., for example. They're actually producing drones, or are working on drones, that if you live in the Seattle area or the Tacoma area or Indianapolis or someplace where they have a warehouse, where if I give an order to Amazon and it's a small enough item, it has to weigh under 5 pounds or something, or 3 kilos, right there, that they would just simply stick it in a box, shove it into a drone, and this thing will fly to my front porch and drop it off on my front porch. And there's no delivery driver, there's no post office involved, and I get the item in the same day, right there. So this again is an autonomous vehicle. Now, what effect is that going to have on, the industry? I mean, first off, the U.S. Post Office, which you don't care about, but Donald Trump obviously does. He keeps trashing Amazon because they don't pay enough for the postage that there. But Trump doesn't like. By the way, Donald Trump doesn't like doesn't like Amazon, not because Amazon does anything wrong, but the guy who owns Amazon also owns a newspaper that doesn't like Trump. So he's mad at the Washington Post, not at Amazon, but he's trying to hurt Bezos, or however you pronounce his name, by criticizing Amazon. Besides, Trump is jealous. I mean, Trump wants to be the richest man in the world, which he's far from. That there, and Bezos is the richest man in the world. So he hates the fact that Jeff Bezos has got a lot more money than he does. Matter of fact, he could probably buy Trump's properties 5 times over. Trump isn't that rich. Everyone thinks he's rich, but he's on the verge of bankruptcy most of the time. Okay, but that's problem 1. Problem 2 deals again with robotics, and I will just simply say the first 3 problems begin with the phrase explain and show how the position and speed or the wiring diagram of a particular motor is taken care of. So in other words, how do you control a servo motor? How do you control a continuous servo? How do you control a DC motor? How do you control the direction and speed of a DC motor? How do you control the an hydraulic motor? How do you control a pneumatic motor? That there. And a hint on hydraulic and pneumatics, if those questions pop up, think in terms of opening valves. When you walk up to your bathroom sink, what comes out of the sink? Water, right? What is hydraulic fluid? It's a liquid, like water. So how do you control how much water pressure that comes out of your sink? By how much you open the valve. So that's how you would control the speed of an hydraulic motor. Is you would open the valve more to make it go faster. You would open it less to make it go slower. So I didn't necessarily cover that in class, but I figured I better throw that out there. It may or may not be on the test. I'm just saying that if I had a pneumatic motor on the test or a hydraulic, it's the same. So, basically the valve. Same thing as if you're putting air in the tire of your car. How fast you fill up the tire in your car depends on the valve in the pump. First off, how much air the pump pumps, but secondly is how much you open the valve to allow the air to pump into. So to A through D, through D really deals strictly with motor control right there. So it's some type of motor control. So I'm asking how you control 4 different types of actuators. When I say actuators, motors, right there. And we only talked about a half dozen, so that should narrow it down to, the 4 questions. You can probably guess what they're going to be, right there. Especially if we did the midterm. Problem 3. Problem 3A deals with sensors. Now, I will tell you the question but I won't tell you what types of sensors that are on the question. The question is, explain the following types of sensors used in robots, along with an example of where each sensor is used. So when I say along with an example, I don't mean the type of sensor, I mean an application. So I have taken off more points for this question in the past, and that's worth 12. There's 4 of them listed, they're worth 3 points each, so that's 12 points there, where you list, you tell me how a velocity sensor works, but you don't give me an example of where you might use it. Right there. And that one's easy. How fast is a robot arm moving? How fast is your autonomous vehicle going down the highway? How fast is your drone flying across the sky? How fast is the fan motor moving that's that's keeping the drone flying? We didn't talk a lot about drones in this class, but drones, of course, are the latest and greatest things that are coming out right there, because, well, I mean, I did mention the military applications for them that there. I mean, they're how the U.S. military has used them in the Middle East for various illegal activities, in my opinion, that there. And I've gone on record as saying that I feel that drone assassinations, I feel, are illegal, that there. But unfortunately, the President of the United States doesn't agree with me and authorizes them, that there. So, but regardless, that there. But if I'm looking at the velocity sensor, how fast is this drone moving across the sky? How fast are the rotary blades turning? So, B is a lot like 1C. It's worth 8 points, and you're given a question there. It's more of a design problem. In other words, I'm going to give you, a particular problem, and you're going to tell me how you would think about designing it. It's not, problem 1C is different, because 1C is the question that involves economic, social, ethical issues right there. 1C is you're given a problem, you're asked to design something. It may or may not be something I talked about in class, right there. Not all test questions are covered in classes when I teach classes, because part of the testing process is challenging your mind to see how you're thinking, right there. Right there. And that gets me into a side note. In the legal term, they call this a sidebar, where the attorneys go off to the side and talk to the judge to argue something. But in my view, in terms of education, it's not my job to teach you how to design robots or how to install robots. I can't do that. There's 3 reasons I can't do that. One is 14 weeks is not enough time. That they're, 4 hours a week, even if I used all 4 hours a week, which I don't. If I use all 4 hours a week, you're not going to become an expert on installing and building and designing robots and PLC systems. That's not going to happen. 2 is I don't have a handful of robots in a lab here that I can put you on to give you practice on. That there. But in 14 weeks, I can tell you what a robot is, when you're going to use it, where you might see them, and then it's up to you as an employer of a particular company say you're going to work for Peridua or Proton or I don't know, what is it, Pensonic? Not Panasonic, but Pensonic up in Penang that builds, you know, electrical appliances, and you're going to be picking robots and putting them on the assembly line. First off, I need you to be able to think in terms of, is a robot an appropriate tool for this job? That's there. You know, should I use a robot for this job? What type of robot should I be looking at? That's there. And then you talk to various vendors, because as far as I know, I've never seen a company in Malaysia that designs and builds robots. You know, they don't, it's not done. I mean, we've got the little toys that we use for this class, but that's basically a 6-motor robot that you find in the Hobbyist magazine that uses an Arduino and 6 servo motors out there. And you can buy the arms from China for 100 ringgits or something like that, or 150 ringgits. You can find them on, they actually sell them on Jalan-Pasar, I think it is. Out there. But in terms of real industrial robots, I have not heard of a manufacturer. I mean, the companies that build industrial robots are almost all coming out of Japan, Germany, the US. Some are starting to pop up out of China, but they're big players with big money to invest in R&D, and most companies here don't have those kind of resources. So when it comes to robots, you're not going to be building and designing robots. So I actually kind of skipped over that part of the course and syllabus, simply because I didn't feel that you're going to be using it. But you do need to be aware of the social that they're. But getting back to my sidebar, is that one of the things that I feel the job of higher education is not to teach skills. Now, employers will argue about that, and some people in the academic world will argue about that. I'm kind of old school from back in the 70s and 80s, and I feel that the university is where you learn how to think. And you start learning how to process your thought process. And, you know, unfortunately, depending on the situation, some people don't think that they want their populations to be able to think clearly. Obviously, a large part of the American population doesn't know how to think. And I have proof in looking at the White House. I can prove that you know, approximately 50% of the voters that voted in the last election don't know how to process information and come to a reasonable, logical conclusion as to who would make a good president. Out there. Instead, we elected a corrupt businessman that likes to lie through his teeth. Out there. That's what happens when a population doesn't think. So democracies require on people being able to think, not just about engineering, but about life in general. And as college graduates, you are going to become leaders of society. And as a result, people in your town, your village, your neighborhood, your families are going to be looking at you in terms of your ability to think properly. That's there. And if I had 3 or 4 weeks to spare, I would probably go off on a side tangent and teach a mini course on critical thinking processes. I think that those of you that can read English well, ask me and I will send you a book on critical thinking in PDF form or ebook format, and you will find that there. And when I talk about critical thinking, I'm not talking in terms of, you know, political, religious, or anything like that.
but in every aspect of your life. You know, you can be a critical thinker and still be a very good Muslim. You can be a critical thinker and still be a very good Christian or Jew. I mean, because faith and religion are based on beliefs and part of the thinking process. But if you're running a factory as a plant manager, you have to make decisions. And in making decisions, you have to undergo a thought process. You should do what, when, where, and why. And why do you know, why would we want to put a robot in this operation? Not because it looks neat and we can brag to our competitors that we're using robotics to build cars. That's the wrong reason to put a robot in. Building the highest building in Southeast Asia is just simply because you want the highest building in Southeast Asia. There's a wrong reason to build the highest building in Southeast Asia. Maybe you need the highest building, but it's because land is at a premium, that the office space is needed, that aesthetically it may bring in tourism. There may be legitimate reasons to build the highest building in Southeast Asia someplace. And of course, the highest building in Southeast Asia is no longer the Twin Towers. I think it's someplace in Taiwan or China. I can't remember the highest building. But regardless, when you make these kind of decisions that involve people's lives, billions of ringgits, you have to go through a thought process. Why are we going to do it? How are we going to do it? How are we going to pay for it? How are we going to do that? And that's all part of the critical thinking process. So problem 3B touches a little bit into that there. You know, and I can tell you that explain how you would design something. And keep in mind that there's no one right answer to those kinds of problems. What I'm looking for is that you think the process through. Okay, that's problem. So I'm just going to put this as a design problem right there, problem 3B. But it's more than a design problem. I'm looking for a little bit of the thought process. 4 is, I will tell you right off, design a PLC ladder logic to control XXX. And I will give you some inputs and outputs. That one's worth 5 marks, and it's a fairly straightforward one. It's one that I've done in class. Right there. Part B, modify your design to do something else. It's an easy modification. Part B is almost a gift. Have you got that? Part C, so this is all PLC simple problems right there. Right there. Part C, I'm going to tell you the problem right there. And there is, explains what meant is by an anti-tie-down circuit and what is it used for. So I talked about it in class. That's a give me problem. I'm telling you the problem right there. I just read it to you. So an anti-tie-down problem, I can tell you the answer, is a circuit that you design to where 2 buttons have to be pressed simultaneously to prevent someone from getting hurt on a cutter or press or something. So I'm going to ask you to regurgitate that information. I just gave it to you. Don't write 3 pages on that. Just simply tell me what it is. I will not ask you how to design the circuit using a PLC. I just want to know that you know what it is and where it's used. Right there. And part D is I give you a circuit and I say, what does it do? In other words, I'm going to show it up from way back here. You can see a little PLC circuit on the top of this page right there. The camera's not on, so it's not being recorded. You can see that little picture. So I'm going to ask you, what does this circuit do? Right there. So, and problem 5, the last problem. And problem 5's got 2 parts. Part A, think last assignment, right there. So on a PLC, use a ladder diagram that you have a pump and a couple of float switches and you have some time delays involved. It's going to look a whole lot like the last assignment right there. So part B, and it actually shows some pictures. And again, I can hold up the pictures. You can see that it looks a little bit like the last project. Not quite the same, but very similar. That there. And, oh, that was part B. That was part B. Part A, I got mixed up. Part A is a motor control problem using a PLC. I'm just going to say you've got some machines, each with start and stop buttons, and you have to limit the number of machines that can run at one time. So part 5 is strictly our two design problems. One, I've told you what it is, because it's going to look a lot like the lab. And the other one is kind of like part 4B, or 3B, is that I didn't tell you how to do this one, and I'm going to challenge you a little bit. All the tools have been taught, but I did not do it as an example in class. I didn't give it as a lab, so there's no real easy way to study for it. Right there. It's more or less if you've understood the labs that you've done, and you have kind of a feeling how PLCs work, that there, or how the design process works, you probably can get most of the points for that. I suspect that on problem 5A, where I did not tell you how to do it in class, I did not give an example, I will probably have a number of people skip that part or not do well on it. And then I'll have some that will do very well. But that's how you end up with some A's in a class and some B's in a class and some C's in a class. If I gave 5 problems and I told you exactly what they were in class and didn't, that there. But again, it goes back to one of the philosophies that I mentioned earlier, is that one of the things that we test in the academic world is the ability to think a little bit. So some of these questions here on this test do come from things other than what I was covered in class. There, you know, I talked about them, but I did not necessarily give you the right answer right there. But the ability to think is one of those key things that I wish I could figure out a way to instill it better, because unfortunately, I don't think you take a course in critical thinking or principles of logic or how, you know, the correct way to argue with people, to analyze arguments. I don't think you take a course like that. There's a course in soft skills, and this kind of falls under soft skills. But critical thinking is a skill all of its own, and it's a science. It's normally taught in philosophy departments in universities, but I consider that probably one of the best courses I took as a young college freshman was the ability, and it was an optional course, it wasn't a required course, but it's helped me make a lot of decisions in life. And I'll be honest, I made a lot of bad decisions in life. You don't get to be an old person and not make bad decisions. And old people are not more intelligent than young people. We are wiser because we have more experiences. But many of those experiences, and I'm quoting a gentleman I'm a huge fan of, that there, Garrison Keillor, he's also from Minnesota, but he's on popular radio host. But he says many of those experiences come from some very unwise decisions. So I've made a lot of mistakes in life. So, and I've learned from some of those mistakes. Wisdom comes from learning from your mistakes. And believe me, I've made some mistakes in life. That there, you know, I made some right decisions too, but I've definitely have made some mistakes. But you're going to make mistakes at there. You know, I'm sorry, some of the young ladies, although there's only 6 of you in the room, so hopefully none of the 6 there might make the wrong choice of a husband. Some of you guys might make the wrong choice of a wife, right? You might make the wrong choice of a career path to go down to. You might make the wrong choice of a piece of land to buy to build a house. You buy a piece of land, it looks like a great piece of land, the views are great, you have plenty of room. Next year it rains and you discover that you bought a lake. Right there. Yeah, I mean, how many times has that happened to somebody you know? You buy a particular brand of car because your friends recommended, and then you discover it spends more time in the repair shop than it does your driveway. Right there. We all make these kinds of mistakes, and they cost us money. They cost us time. They cost us heartache. You know, when you make the wrong choice, say in a spouse, you know, there's a lot of heartache. You know, I've been through a divorce, and you know, out there, and there's a lot of hard feelings, a lot of bickering, a lot of hurt feelings, a lot of nights that you've been crying, upset. Out there, there's a lot of pain involved, and if there's children involved, then they suffer a lot of pain. So bad choices are not, you know, you should be avoided, but you're going to make them anyway. So you learn from them. You try to avoid them in the future. So, okay, that is it. I've got on my soapbox. I've did my little thing. I'm going to stop my class, 37 minutes, which is